So you may have used the new input system before, and chances are you did so by adding a player input component, use the default input mappings, and you probably used the send messages behavior or invoke Unity events, and then just use this player input component to manage all your input. This probably worked just fine, but it didn't feel quite right just using built-in components for something that could be built yourself. And since you're running low on things to procrastinate with, you want to dive into making a perfectly scalable input system, even though what you already have is just fine for your prototype. That's where I come in. I will give you the satisfaction of learning how to architect a scalable input system in this video. So what I will do is explain a simple diagram to try to visualize how the system is going to work. Then I'll implement an input system based on what I'm talking about, and I'll try to do that as simply as possible while still getting the message across. Okay, first we need to visualize how we should be interacting with the way Unity presents their input system. Let's say this is a PS4 controller and you press the X button on here. Unity takes that, does a bunch of stuff in it that we don't really care about, and it eventually comes into this input map here that we have defined as the game developer. And it ends up determining that, okay, they press the jump button, the input map will fire this on jump event, and then in our scripts that we want to handle input in, we will say, okay, the on jump event was just fired, now what do we do with that input? And we'll get a bunch of information about whatever the input was. So this on jump event will be sent with a context parameter, which gives us all the information about like whether the event was fired because it was just pressed, whether it was because it was canceled, and then if there's certain value that comes with the input, that will be inside of the context. And then we'll have to process that all inside wherever we're actually handling that input. And this is pretty much exactly how that player input component works. It takes the input mapping asset as a serialized variable, and then we can process that however we want in the controllers that we're building ourselves. Now this is fine, but it's not perfect. It's not giving us that feeling that we're actually being programmers here. Particularly because in every new script that we have to handle input, we have to break down the context parameter, which can actually get pretty complex. And we just have a bunch of boilerplate code in every single script where we're dealing with parsing the context and figuring out exactly what this event means. So instead, what we're going to do to get rid of that feeling is, of course, slap an abstraction in between the input map and the controller scripts where we want to be putting into action what we're getting as input. So this input reader that we're going to make is going to be similar to how the input map already works. It's going to be an asset. We're going to write it as a scriptable object, so we'll be able to create an instance of it within the project folder itself. And what we're essentially going to do is take the events that we're getting from the input map and process the context inside the input reader, so that we're essentially creating our own API based on the requirements of our game, rather than dealing with that individually within each controller script. So in this video, I'm going to do all of this stuff from scratch here. I'm going to create the input map from scratch. I'm going to create the controllers from scratch. And then I'm also going to create the input reader and try to convince you why that layer should be there. Now, I will be using interfaces and events in this video, so if those are unfamiliar topics to you, this might be a little bit harder to follow. Now, I still encourage you to watch this anyways, because hopefully I'll be able to explain it simply enough where you might not fully grasp the idea of those concepts, but the video might still make sense. But regardless, I highly encourage you to learn about both events and interfaces if that's the case, because they come up all the time in game development. Okay, so let's get started making this input map. So the first thing that you're going to want to do is make sure the new input system is actually in your Unity project, because it doesn't come by default. So you do that by going to the package manager and then making sure this section is on Unity registry, and then just type in input system. And then there'll be a little install button if you don't have it in your project already. And then it'll probably tell you to restart Unity if it's not installed yet. First thing we want to do once we're back in Unity is create our input mappings, and you can do that by right-clicking the background of your project folder, click create, and then for mine it's right at the bottom. Input actions is what we want to create, and I'll just name mine game input, and then if we double-click that to open it up, it gives us a completely empty input mapping. So for this video, I'm not going to do any fancy input. I only want to demonstrate the foundational layer between the input mapping and the end scripts that use the input. So we're just going to create two basic input maps, one for gameplay and one for UI. In the UI, we're not going to do anything. We're just going to have, in the gameplay, we're going to have an action for pausing the game, and then we'll just resume it in the UI. I just want to have the two maps just to demonstrate the difference between the two. In gameplay, we're going to have three actions. The first one's going to be move. And this is how we want to handle the movement input. So because this requires a value based on our input, so let's say we did WASD keys, we want to differentiate between the values. we are going to change the action type to value instead of button. And if you hover over action type, you can read exactly what it does. But essentially, the value action type means that every time the input based on this action changes, it's going to re-trigger the event that is caused by this move. And if it's not clear, each action that we create will have its own event associated with it that will have context about that input event. And we'll get more into that later. For movement, we also want to change the control type to vector 2 because we want two-dimensional input on this. We want to be able to walk forward and backwards, which is the y-axis, and we want to be able to walk horizontally left and right, which is the x-axis. So a vector 2 will give us that information to be able to do that. The next thing we have to do is create bindings for this move event. The other nice thing about the new input system is that it allows us to have multiple different types of inputs very, very easily. So in this video, I'm going to use both the keyboard and my PS4 controller to handle input, and we'll see the differences between the two. So to add the keyboard input, I'm going to click the plus button here, and then I want to add an up, down, left, right composite for the WASD keys, which I want to use to control movement. So I'm just going to call this WASD, and then it gives us a mapping for each direction. And this correlates with the vector 2 that we're getting here. So we're going to map each of these keys to WASD. So we have that, and then we also want to add another binding for my PS4 controller. So I'm going to add just a normal binding for this one because we're going to be using the stick movement for the PS4. So we don't need up, down, left, right for that because it's just a single input on the controller. And for my PS4 controller, I can use the gamepad mapping. So I'll assign the left stick to that. Okay, and that's all we need for the move input. We also want two more actions that will be a little bit more simple. We want a jump action. We'll just call that jump. And for this one, we're going to leave it as a button because all we care about is whether the player presses jump or not. We just want a trigger event. And then we'll bind the spacebar to that. And then for the gamepad, we'll just say the button south. And that is the X button on my PS4 controller. And then we're going to add one more action called pause, so we can pause the game. And once we're building the input reader, we're going to make this pause action completely disable gameplay input so that we're only listening to UI input. I'll show you how that works when the time comes. So this one we're going to, let's just say backtick for no particular reason on the keyboard and start on the gamepad. Okay, so we got our three actions for gameplay. We're going to add one action to UI, and that's just going to be resume from the pause state. So we'll set that to the same mapping as pause. Okay, so we set up all our actions. Make sure we save that. And before we close this window, if you look at the inspector while the window is open, you can see there's this generate C# class. We want to check that off because we don't want to be using this input mapping asset anymore directly. We want to access the code that is being generated by this directly instead. So I'm going to put this in a new folder. In scripts, I'm going to create an input folder. Leave it named as game input. Add my namespace and click apply. Once that's done, we can go into that folder and then we can take a look at the script that we just generated. So right at the top of the file, we can see a huge wall of JSON text. And essentially what this is doing is just defining exactly what we just defined in our input mapping window. So you can see for the gameplay action map, we have each of our events, move, jump, and pause, and then all of the bindings that correlate with those actions. Then if we go a little bit further down the file, we can see a bunch of stuff being defined. And don't worry if you don't understand all of this stuff going on right here. There's a lot, and it's not really all necessary to fully grasp. But we can gather a few things from this file. So we can see there's a struct made for each of our input mappings. There's gameplay actions, and then there's UI actions. And then within each of those structs, we see these events being set in here. So for each of our input actions, there's an event that's named based on what we named it with an on prefix in front of it. So there's on move, on jump, and on pause. And then the same thing for the UI map. It's also telling us that there's three input events that are each being mapped to the same handler. So there's the started, performed, and canceled event. We'll take a closer look at these when we start creating our input reader. But for now, basically what's happening is started and performed both fire when the key is pressed on a keyboard, and then canceled is called when the key is released. And you can see that all of these are being mapped to the same handler. So we'll have to break this down inside this handler when the time comes. The last thing we want to look at in this file are the interfaces that are created. So these interfaces are how we're going to create our own API for our input system. We will be implementing both of these in our input reader. Okay, next thing I'm going to do is add the input reader. So this will be the layer between the input map and our controllers. I'm going to put this in the input folder with the game input. And I'm just going to call it input reader. So right away when I open it up, this is not going to be a mono behavior. Don't need the awake function. Don't need mono behavior. Instead, we're going to make it a scriptable object. And to go along with that, we are also going to create asset menu. And we're going to call it input reader. And if you're not familiar with scriptable objects, all this is doing is adding an option to the context menu in our project window that allows us to create an instance of this asset that we're creating right now in the project folder. We're also going to want to use the interfaces that were created in game input. So we're immediately going to add the iGameplay actions and the iUI action. And then we'll need to implement these interfaces. If you're using Rider, you can just go control dot and then it'll give you an option to implement the missing members. I'm just going to implement all of those. If not, you might have to put this in manually. But this is what it should look like once you implement all the members. We're not going to fill these out yet. So first we're going to create an instance of the game input object. We'll just name that game input. And we need to map what's going on in this game input file into our new input reader. So all of all of these get triggered based on the input map. So we want to do that automatically. So we'll do that in the enable function. And then we'll just make sure in here if game input is currently null, we'll instantiate it. And in that game input object, they give us a function to map the events defined in here to the events defined in game input. And that would be independently in each of the mappings that we've created. So in gameplay, there's a function called set callbacks, and we'll just set it to this. And then we'll also do that for the UI. So as we discussed in this diagram here, we don't want to just directly deal with this context parameter because there's a lot of information in here and we don't want to digest that every time we create a new controller script that needs input. So instead we're going to create our own little API that makes it simpler to handle input when the time comes. So the way that we're going to do that is just create our own public events. And we want to make this as simple as possible for the controllers in the end. We're going to make our own events. For move, I'm just going to create a move event. That is an action that only sends in a vector 2. And this is going to be the value that we want to be moving by. And then we'll just call this move event. So that is going to be the event that we want for movement. For the jump input in this game, I want to know two things. I want to know when they hit the jump button to make them jump. And I also want it to jump higher the longer that they hold spacebar. So the other thing that I want to know is when they let go of spacebar so it doesn't jump as high. So I'm going to create two events for this one. And there's going to be no variable passed in this one because all it is a trigger. So we're going to call this one jump event. And then we'll also have a jump canceled event. And then we're just going to have a simple event for pausing and then the same thing for resuming. Now, again, if you aren't familiar with events, this might be a little bit confusing to you, but again, I highly encourage you to learn about events at your earliest convenience because they are incredibly useful. The last thing we want to do before we implement these events is make sure we have the right input mappings enabled. By default, the mappings are disabled, so we need to do that manually. And to do this, we're going to make some functions that make sure only one input mapping is enabled at a time. So we'll call one set gameplay. And then there's a function that is just called enable, and that enables this input map. And then we want to make sure when gameplay is enabled that UI is disabled. And then we want to do the inverse for the UI. So we'll set UI and then disable gameplay and enable UI. And when the game starts, we want to make sure gameplay is enabled by default. Yes, I know menus are usually the first thing you see in games, don't worry about it. And now finally we're going to start looking at these interface functions. So the first thing I'm going to do here is just send some logs to the console to see exactly what's going on. And we're going to log two things in here. We're going to show the phase, which will be, as we saw before, started, performed, or canceled. These are the phases that exist. So we want to see what the phase is when we hit input. And we also want to read the value. And this is kind of the obscure way to get the value of the input out of it. They use generics. It's a little bit confusing, but you can read the documentation here. They have it documented okay. It gives a little bit of context on what's going on. But anyways, let's take a look at what this does. The first thing we need to do back in Unity is create the input reader asset. So we can see with the create asset menu tag, this should appear now right at the top. And we have our input reader asset. So if we just start the game, we can see if it logs to the console. So if I press W, I'm holding it down right now, it sends a started and a performed event. And we can see that it's positive on the Y axis, just as we expected. And then when we let go, it sends the canceled event. So this is a little bit different from the old input system where you might have been using the get key function on a certain key code. And that would just, every frame that the button is being held down, it sends the value of that button being held down. This is not the case here. We're not getting an event sent every frame. We're only getting it sent on the important frames where the value changes. We can also see if let's say I press W and then press A while still holding the W key. We get another performed event, but we don't get a started event. We only get the started event when any one of the input mappings is pressed for that input. But if the input is changed but not canceled in that time, we don't get another started event. So we only get one started and one canceled event for each amalgam of input interactions for that one input action. We can also see the same thing happening for the gamepad. So I just picked up my PS4 controller, and we can see that when I move the stick around, we can go to the top and we'll see one started event, but then we just get a ton of performed events every time I move the stick even a little bit. So this event is getting triggered anytime the value of the stick changes. And then right at the end, we get a canceled event and it resets back to 0. So based on these logs, we can determine exactly what we want in our player movement script. Every time the value changes, we want to know what that value is, and that's exactly what we're set up to do right now. So if we go back to the script, get rid of this debug log, and this onMove function is going to be very simple because we know that every time this event is triggered, we get the value of what's being sent in the input. So all we want to do here is invoke the move event, and we want to check to make sure it's not null first, and then invoke that and send in the vector2 that goes along with that input. So in this move event, we'll always know exactly what the input is. The button events will be a little bit different because we depend on what the phase is a little bit more. So in the jump event, we want to send the trigger on the performed phase, and then we want to send the jump canceled event on the canceled phase. So these will just be simple if statements to handle that. And this phase variable is just an input action phase, which is just an enum. So we can check whether it's performed, canceled, or started. If it's performed, we're going to want to invoke the jump event. And there's no variable in there, so that's all we need to do for that. And then it's going to be the same thing for the canceled phase. If the phase is canceled, then we want to invoke the jump canceled event. For the pause and resume event, it's kind of going to be the same thing here, but we also want to change which action map is enabled based on whether we're pausing or resuming the game. So if we're pausing, we're going to invoke the pause event. We're also going to set the UI to be the enabled action map. And then it's going to be the inverse for on resume. So we're going to send the resume event, and then we're going to set gameplay. And with that, we have pretty much created everything we need to interact with our input events in the simplest way possible. So the next thing we're going to do is set up the controllers to handle these events that are being triggered now. So I'm going to go into my scripts folder and then create 2 scripts, one for the player and one for the game manager. To not make this too complicated, I'm going to keep these scripts very simple. It's not going to be any complicated input. I just want the player to move and jump, and I want to be able to pause. So I'm just going to speed through writing this script right now, and then I'll explain what's going on afterwards. Okay, so our player controller is all set up here. The first thing that we need here is the input reader asset that we just made. We need a reference to the events that are going to be triggered. And then there's just some speed variables to control how fast the player is moving and jumping. We also want a move direction vector to keep track of what the input is, because as you might remember, performed event only gets triggered when the value changes. So you might be holding down a button, but it won't send an event every frame. So we need to make sure we record what the last input was so that we can persist that input as long as it doesn't change. And then we also have a state handler here to check if the player is jumping or not. We'll also set up some functions to subscribe to the events that are going on in the input reader, so we get notified with the proper information when the inputs are pressed. And then in these input handlers, the functions are very simple because we're getting exactly the information that we need. When we want to handle movement input, all we're getting is a vector2 with the direction of the input. And then for the jump, all we're getting is a trigger whether the jump input has been pressed or whether it has been canceled. And all we have to do is set the state based on that. And then we have these move and jump functions to perform every frame based on what we're getting from the input. You might notice I'm doing a little bit of remapping in the move function here. And that's only because I want the forward direction to be the x-axis in game. I want the horizontal direction to be the z-axis in game, just based on the way that my map is set up. You can see here that forward facing is along the x-axis and then horizontal is the z-axis. That's all I'm doing here. Okay, and finally we're going to set up the game manager to handle the pause and resume state. This is also going to be a pretty straightforward script, so I'll just speed through this and I'll explain it after I'm done writing it. Okay, once again, very simple script. All I want here is a reference to the input reader so I can subscribe to the pause and resume events. And then in those handler functions, I'm just going to set this pause menu asset that I have set up in game, set it active, and then turn it off when the game is resumed. So everything should be set up as it should be, and now we'll test it in game, see if it works. But before we press play, we do have to set up a few serialized variables. So if we go to player, we need to make sure the script is actually attached first. Add the input reader to the player controller, and then set up the speed. I'll just try 10 and 5 for speed and jump speed. And on the game manager, we need to attach that script. And then once again, add the input reader and a reference to the pause menu object. And now we can press play and test it out. All right, obviously the animations aren't working, but we can see that the player is moving forward, backwards, left, right, and also jumping. The jumping feels a little bit glitchy, but that is probably because we have a rigid body in there, and it's fighting against the transform. Like I said, this video is not about implementing amazing player input. This is only about crafting an amazing input system. Quickly test out the PS4 controller. Looks like that works too. Smooth movement based on the stick. X button works. And then the pause menu. Oh, look at that. This button isn't working for me for some reason. Maybe you can check it out, see if it works for you. Now, I don't know if you can hear that, but I'm trying to apply movement input while the pause screen is up and nothing is happening. And that is because the gameplay input mapping is disabled when the pause screen shows up. And then if I disable the pause screen, we can now start to move again. And that's pretty much all I have to show you. Hopefully there were some things that clicked in this video to help you see why adding a layer for your input system can help make your game a little bit more scalable. Now, you might have noticed throughout this tutorial, if you've ever looked at Unity's open projects, that this is very similar to the way that they architect their input system. I did this because I love the way that they set up their input reader, and it was a little bit complicated to look through, especially if you're kind of looking at the new Unity input system for the first time. So I wanted to break it down as simply as possible and kind of make it a little bit more digestible. So if you want to see a much larger scale implementation of what I just did in this video, I would highly recommend checking out this project and just kind of going through the files. It's completely open source, great resource to learn about not only the input system, but about making a larger scale game. I'll put the link for this in the description, along with the documentation for the input system. But with that, that's everything I have. Hopefully you feel a little bit better about your input system after this. If you feel like a better programmer after this video, please give it a like. And I plan to be making more videos in the future, so subscribe if you want to see more.